auto turn off. All right, so I'm still Tyler, now with a slide. A grad student at the University of Chicago, studying computer science, advised by Kyle, Chardney, and Foster, and working with a lot of the people in this call. I'm going to tell you guys a little bit about a distributed metadata extraction system we built on top of FunkX. And so just to provide some quick motivation, data, like lots of us are scientists, we know the data research lifecycle. You acquire data, it creates data, you clean data, more data, you use data, it somehow creates more data. And ultimately as scientists, we end up with this big old snowball of data. And when all the scientists decide to push all of our data to these storage systems, the dream is we have this thing called the data lake, this rich searchable collection of storage that basically is something that we can use to promote further science down the road. But that is not always the case. And we create these things that are called data swamps, or these collections of data that are difficult to navigate, missing critical informational elements, or files that cannot just be accessed, discovered, or reused. So how do we turn this pile of data into something usable by the sciences? To avoid data swamps, we need an index of rich searchable metadata, right? We can't, navigate our data unless there's a means of doing so. And so what do I mean by metadata? So when I talk about metadata as we keep going, I refer to two types of metadata. So we have content-based metadata, like what could be inside of your files. Like for example, we have this picture of a dog, it's an image, it's a photograph, there's dogs, trees, and leaves, that's the content. But then you also have some context that a lot of people search on, such as how big is the file, when was it created, when was it added to the repository, who owns it, who has access privileges, so on and so forth. And so we call this act of taking this metadata out of the data, metadata extraction. And so we built a system to extract these metadata, and it was pretty nifty at the time. This was, I guess, around 2018, it was mostly in use. You had a scientist, he SSH'd into his computing system. This is an example on a Jetstream cloud node. On that system, you had this library of different extractors that can be, applied in modular ways to, or I guess you could link them, I suppose would be the correct word, on files in order to get some amount of metadata out of them with this kind of orchestrator or scheduler, as you would call it, sitting here making decisions as to which extractors are applied to which files. So this is really fast, this is really great, but we know the data are huge, not necessarily constrained to one node, and this is difficult to just take out of the box and run on this computer versus that computer versus that computer. Thankfully, FunkX came into being, which allowed us to solve literally all of these problems at once. And so Extract is our system now that remotely orchestrates extraction plans across these distributed data that can exist across these computing facilities. And so what it does is it leverages FunkX to enable scalable and remote execution of lightweight extraction functions. So on this last slide, when I showed you this extractor library, like for example, the tabular extractor, all it is it's a function and a container that has all the dependencies for that function, which fits really great into the FunkX ecosystem that allows you to run your FunkX workers as containers, right? And so basically, if you can, launch a FunkX endpoint at your facility, and you can have this library of containers at your facility, and even in the future with that container service that was mentioned earlier, be able to automatically, organize and shift these containers from one type to the other. You can imagine this really awesome automated ecosystem where you don't even have to move data unless absolutely necessary, and process across multiple compute endpoints regardless of the computing infrastructure, right? And so how this goes is when a user starts a job, it starts off by crawling all of the endpoints. It basically just creates this giant master list of data. It makes and executes processing location decisions for each file, so it determines where they should go, subject to all sorts of user configurable scheduling rules. And then it executes that extraction plan by applying extractors to files. And so how does it do that now versus in the local use case? Is that all of that decision making is happening centrally at a extraction service, but then making calls to actually send the extractors to the files via the FunkX web service. And so some quick things about FunkX that we use to make this go fast is we use batching, so we don't make a million requests, even though definitely over time, and most of the people who handle the FunkX infrastructure can say, I've sent a lot of functions doing metadata extractions. And most of the time now, I don't break things, which is good. And so I can show some results from a recent paper we wrote. So here is us running a bunch of these extractors on an HPC cluster, or I guess this is Theta, as is at Argonne, familiar to a lot of you. And so we took the image extractor, the material science extractor, ran it a whole bunch of times and saw that it was scalable to over 2,000 concurrent workers. Now that number is expected to be much higher because we've created all sorts of optimizations where we send less data through FuncX, which is kind of a strategy we sort of live by, where, you know, the less things you have to send through FuncX data-wise, the faster your function can get from your machine to the endpoint and back. And so we've made optimizations, but even back then, what was this, like a year ago, our results looked pretty good. We did batching both on the app. We explored batching both on the application side. So, you know, making our own objects, you know, batched, and then using FuncX batching to limit our number of requests. And we kind of found this nice little sweet spot where, you know, we could push things through with maximum throughput. Here we explored a little bit of what happens, you know, let's say you have to move your files from a computer to another computer and then extract them. That's great, because if you have all sorts of FuncX workers available, you can extract roughly as fast as you like the transfers arrive, because transfer becomes the bottleneck, which is exactly what we wanted to see. And we showed that we can process the entire materials data facility, which at the time was 60 terabytes, in just over 6 hours. And there's some funny bumps and things in this graph that we were exploring at the time. If I had more time, I would talk about them. And finally, talking about the flexibility of the approach. And so FuncX has been particularly cool in that we can run on supercomputers and laptops. You can also just, you know, launch this thing, as others have shown, on a Kubernetes cluster. So here we just took all sorts of our extractors, plugged the orchestrator in the exact same way, and FuncX figures out how to, you know, mix and match the containers appropriately on the Kubernetes cluster. So it fills the pods automatically. I always find that to be cool. It's like Kubernetes magic. And so in conclusion, Extract enables metadata extraction on big data, distributed data, heterogeneous cyber infrastructure, and all of the challenges therein. It's pretty much abstracted away. And Extract overall is made possible by FuncX. Any questions?
Cool. I've got a question.
Yeah,
how are you coordinating the transfer of data and the execution of tasks? Are you doing anything sneaky there to try to line things up?
A little bit. So basically, we've just kind of used like some basic rules in play where we try to keep containers warm. So the idea being that you want to send as many tasks of the same type, or if a task is, you know, dominant on one of the machines versus another machine. So let's say you have a machine that has a ton of tabular data, that might become your tabular data machine. So I've explored rules for like that sort of thing. And then all of the tabular data move there just to minimize the number of, you know, cold restarts. But other than that, it's just kind of like two-phase scheduling. So phase one, put the data where it needs to go. Phase two, send the extractors. And each has its own set of scheduling rules.
Tyler, I have a quick question. So
Sure.
if I were to try and run Extract on my own, how would I go about doing that?
Good question. I have some notebooks available for people looking to run Extract. I know a lot of people at the materials data facility are using it for various things. So if you're using an Argonne or cloud resource and are pretty familiar with FuncX endpoints, like shoot me a message and I'd be happy to help you out.
All right. You should probably put a link to those notebooks on the slide. Probably
Sure.
would be useful. Yeah.